Polyethylene terephthalate, or PET for short, is a condensation polymer made from the monomers terephthalic acid and ethylene glycol. The 3D ball and stick models illustrate the structure of these molecules. Terephthalic acid has a cyclostructure and is on a singular plane, whereas ethylene glycol has tetrahedral characteristics. As you can see, terephthalic acid has 2 carboxyl functional groups at each end of the molecule, and ethylene glycol has 2 hydroxyl functional groups at each end. It is these 2 functional groups that react together to create an ester link between the molecules. Since this is a condensation reaction, water is one of the products that is formed. Now with the water out of the way, we can see the ester link form between the alcohol and the carboxylic acid. The ester link is highlighted here. This process continues between carboxyl functional groups and hydroxyl functional groups, as more and more ester links are formed, creating longer and longer molecules. Just like polyvinyl chloride, polyethylene terephthalate will have thousands and thousands of repeating monomers in one molecule. To create PET with different properties, different levels of heat and different catalysts are used to influence the reaction. PET's ability to be modified is one of the reasons why it has so many applications. For instance, it can be used in plastic milk bottles, as well as being woven into fibers to be used in clothing. When we look at the ball and stick model of PET, the ring structure that is repeated through the polymer is very noticeable. This ring structure is what gives the polymer strength and stiffness. One of the main disadvantages of PET is the ester link that can be seen repeating through the molecule. This is because ester links can easily be broken down by acids and alkalis. For this reason, additives such as antioxidants are often added to PET to increase its resistance to chemicals. The ball and stick models also illustrate that the PET molecules aren't straight, they are quite curly and wavy. This makes PET usually amorphous in structure, and consequently clear. This is why PET is often used in plastic films and plastic bottles.